Hi everyone, welcome back to our series. Hope you are doing good. This is Mahesh. In this video, we will continue on solving Leetcode problem number 136, single number. So what this problem statement states, given a non-empty array of integers. So it means we will have some elements in the array nums. Every element appears twice except for one. Okay, find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. Okay, now there are some examples they have given, and after that let us see the constraints. So the length of the nums lies between 1 and 3 into 10 raised to 4, and the number in the array, it ranges from minus 3 into 10 raised to 4 to plus 3 into 10 raised to 4. Okay, then there is one more constraint which is very important one. Each element in the array appears twice except for one element which appears only once. Okay, let's switch to the editor. So this is our standard structure for this entire array series. So this is we are following so that we will be well prepared for the interview. So with that, let us start. Let us try to understand the problem. Here, what they have given nums array and it contains numbers. Okay, and each number will appear twice in the array. If you see here, 2 appears twice, 1 appears twice, but there will be one number which appear only once. Okay, so one number appears once, so we need to find which is that particular number. So with that, we also understood the constraint. For sure there will be one number which appears only once and the remaining numbers appear twice in the array. So this is pretty much clear. Now what you can do, you can think for a second. So you can pause the video, and then if you get any possible solution, then you can try to implement that, or else you can proceed with the video. Now with that, let us try to come up with some brute force solution for this problem. So now what will be the extreme naive or the extreme brute force solution for this problem? So what I will do, I will take this number, then I'll scan the remaining elements. Okay, so if this element repeats, then I will continue to look for the next number. Okay, maybe next number is 1 here. So in this array, the first number is only the number which appears once. For now, you consider this number 1. So if you scan the entire array except this one, you will get one more 1, correct, right? Then if that is the case, then that is not the number. Now if you take 2, if you scan the entire array, there is one more element which is 2. So it means it appears twice. So that is not the intended number. If you see 4, if you scan the remaining elements in the array, it is not appearing again in the array. So that means that is our intended answer. So with this, let us try to write the pseudocode for this one. So what I will do, I will take a for loop for I equal to 0, I less than, so n will be nums dot length. Okay, I less than n, I plus plus. Okay, then I will have to take one more for loop so that I can scan the remaining elements. So before that, what I will do, I will take a flag. So that is repeated, and I will say it is false initially. Okay, so we will use this flag further. We will see that how we will use that. Then I will use for j equal to 0. So here we should start from 0 itself because we will have to scan all the elements. J less than n, j plus plus. Then I need to check if I is not equal to j. This is very important because if you compare the number with the same number, then for sure, I mean, this number will be repeating, right? So, but that should not be the case. We should leave that number. So I should not be equal to j and nums of I. If it is equal to nums of j, then what I will do, I will say is repeated equal to true, and I'll break the second for loop. Why? Because there is no need to continue, right? I mean, once you found the second element. So I will break. Then at the end of the second for loop, maybe I'll put a bracket here. So assume our first for loop ends here. Then what I will do, I will check if is repeated. If it is repeated, basically we should check if it is not repeated. If it is not repeated, or for your understanding, I'll remove this. If it is not true, means it will be false. So if it is equal to false, then what I will say, we got the non-repeating number. So I will return nums of I, because I found the number. Now I will close this, and finally at the end maybe we can simply return -1. So ideally, I mean, this will for sure give us the intended output. If you see this, what we are doing, we are iterating over the array. Again, inside this for loop, there is one more for loop to scan the remaining elements. So its time complexity is of order n square. Okay. But if you see the space complexity, it is not using any extra space. That's why space complexity is of order 1. Okay, so this is extreme naive solution. Is there any way you can improve this one? Let's see. So we have this array 4 1 2 2 1 2. We have 4 1 2 1 2. This is our array, correct, right? Now what I will do, I know, I mean, each number will appear for 2 times except only one number. So what I will do, I will simply sort this one. So if I sort this one, how it will look, 1 1 2 2 and then 4. Okay, let us assume we have 2 more numbers, maybe something like 6 6, something like this. That way, I mean, it becomes easier for us to understand. Now it is 6 and 6. Okay, so if you see, the number appears twice, this number appears twice, but if you see, this number does not appear twice, but these two numbers, they again, I mean, this number appears twice. So if that is the case, how I will compare? I will compare this number with this number. If it is same, then I'll continue. Then I will move to next number. Then I will compare this with next number. Then if they are same, I will continue. Now, if you see this case, now I will check my number and I will compare it with the next number. Okay, so in this case, it is not equal, correct, right? So if that is the case, the first number here will be my intended output, because it is not equal to the remaining, I mean, the next number. So this way we can sort and we can come up with the single appearing number. Okay, let's try to write the pseudocode for this one. So now what I will do, I will first sort my array. So nums equal to sort nums. Okay, so this one will give me the sorted array. Now what I will do, I will use for loop. So now we don't need two for loops. We can, with a single for loop only, we will be able to find. So I equal to 0, I less than n. Okay, I equal to I plus 2. I will try to skip a number and jump to the next number. So now what I will do, I will check if nums of I, if it is not equal to nums of I plus 1, then I will simply return my nums of I. Okay, this way I will found the number. Now if you see, with this we found the number, then what we can do, we can simply close this, and here just to return something we can simply return -1, otherwise our functions will give error. Now if you see this one, this will for sure give us the output, because there will be one number which appears only once and the remaining numbers will appear twice for sure. That's a constraint, right? So it won't come here. So with this, if you see, now what we are doing, first we are sorting and then we are trying to check it with the next number. So what is the time complexity here? Time complexity will be, for sorting, it will be of order n log n. Okay, then we use this for loop which is of order n. So somewhere it is close to order n log n. So this is our time complexity for this particular solution. Okay, now what is the space complexity? So it is of order 1 again, because there is no extra space that is used. Okay, so is this the best solution? Again no, because it still takes order n log n time complexity. Okay, so now let us try to again dive more and try to optimize this. So if it is taking n log n, the next possible solution would be of order n. Okay, so let us try that. So now the next thing what we can do, maybe I will take the array again. So now what I will do, I will use the hashing technique. So hashing technique, what exactly does, we will simply count the occurrence of each number and we will check which one gives us single count. So now what I will do, 4 appears once. Okay, 1 appear here, 2 times, again 2 appears 2 times, 6 appears 2 times. So which appears only once? Our 4 appears only once. That way we can return this answer. Okay, let us try to write the pseudocode for that. So now for I equal to 0, I less than n, I plus plus, what I will do, I will have my hash map. So this is my hash map, or in JavaScript it is map, simply map. So hash map equal to new hash map. So it will take integer comma integer. So we will see that in the code. So this is my hash map. Now what I will do, I will simply count, that is map dot set in JavaScript and put in Java. Then what I will do, I will use nums of I as my key. Then I'll remove this. Then map dot get in JavaScript and get or default in Java, so you can use that. So I will send my nums of I. This will give me the existing count if there is, or else we will have to consider 0 here as a default number. Then I'll add 1 to it and then I will set the value. This way it will prepare this particular hash list for us. Okay, after that what I will do, I will iterate for each key in map. Then I will check if map dot get of key, if it is equivalent to 1. So get of key will give us the value. basically this value, this value, and we will check which one is 1. If it is 1, then what we will do, we will return that particular key here. Okay, so here what we did, we used a for loop, okay, which is of order n. Okay, then we used a map. So map, basically, since each number appears twice and only one number appears once, it hardly takes order of n by 2, which is close to order n. So if you see, the total time complexity for this solution is order n plus order n by 2 plus 1. So which is close to order of n. Time complexity for this solution is order n. But what about the space complexity? We are using a map, right? So map will occupy extra space, so which is of order n by 2 in worst case. Not in worst case, in most of the cases, n by 2 plus 1, so which is close to order of n time. So space complexity is order n for this solution. If you see, we are able to find the solution in order n time complexity. Okay, so this is a little bit, better solution compared to other solution, because we are able to find the answer in O of n time complexity, but with some extra space. Okay, let us try to execute this and let's see. Let's take a hash map of integer comma integer. Then I will call it as count equal to new hash map. Okay, so now let's use a for loop for int num colon nums. This will give iterate over each number. Then I will count it. Count dot put of key as number. Then value will be count dot get or default. This will check if there is something with that particular key, or else it will give us 0 value. Then I will add 1 to it and I'll give it as value for the counter. Okay, now after this I will use for int number colon, so count dot key set. This will give us the available keys. Then I will use each key, or that key will be called num here. So if count dot get of num, if it is equivalent to 1, then I will return that particular number here. Okay, so I will have to return -1. This way it won't throw error, but for sure we will get the output on line number 10. Okay, let me try to run this. It got accepted. If I submit, it got submitted. So now, do we think, this is the most optimal? No, right? Because it is using some extra space. So here the interviewer will be expecting us to solve this in order n time complexity and order 1 space complexity. So how to solve? So for that, we need to understand how the bit manipulation works. So basically, whenever we store a number in in computer, so it gets stored in bits, right? Zeros and ones. So now we know XOR operator, right? What exactly XOR does? So XOR will, if the bits are different, then it will give us 1. Zeros or 1 will give us 1. But if bits are same, then what it will give? It will give us 0 in that case. It will give us 0 in that case. Okay, so this is basic principle. So if that is the case, then assume you have some number, maybe 6. Then if you XOR it with 6, what you will get? So let's write that 6 will be represented as 0, 1, 1, 0. Correct, right? Now again it should be XORed with 0, 1, 1, 0. 0, 0 will be 0, 1, 1 will be 0 again, 1, 1 will be 0 again, 0, 0 will be 0. So if you XOR any number with itself, then it will give us 0. It will give us 0. So if that is the case, then here we know, right? I mean, each number appears twice. So if you take the example again, 4, 1, 2, 1, 2, then 6 and 6. Now what I will do, I will try to XOR the numbers. Okay, so if I XOR 4, XOR 1, XOR 2, XOR 1, XOR 2, XOR 6, XOR 6, then since 1 appears twice, it becomes 0. Since 2 appears twice, it becomes 0. Since 6 appears twice, it becomes 0. Now if you XOR anything with any number with 0, then it will give that number only. Okay, so we can see that here. If everything is 0, then it will be 1, 1, right? It is 6 only. Correct, right? So now these everything will give us 0. Now 4 XORed with 0 will give us 4. So what is the output that we are expecting? That is 4, right? So this is how we will be able to get in one iteration without using any extra space. We don't use any counters here. We simply keep on XORing the number. So let us try to write the pseudocode for that. Let us say result equal to 0. This is answer that we are expecting. Then what I will do, I will do a for loop for I equal to 0, I less than n, I plus plus. Then what I will do, result equal to result XOR nums of I. Okay, so this way, if you simply return the result now, what it will give? It will give you the intended output. So what this is doing? So initially result is 0. Okay, then what it did? It XORed it with 4. Okay, then what it did? Then it XORed it with 1, 2, 1, 2, 6, 6. So this is the total XOR equation. So in that case, 1, 1 will end up giving you 0. 2, 2 will end up giving you 0. 6, 6 will give you 0. Then this is anyhow 0. 0 XOR with the remaining 4 will give you 4. Okay. So if you see, this is the most optimal. This uses order of n time complexity and space complexity is of order 1. So this is the most optimal solution for this particular problem. Okay, let us look that in action. Now I will comment this. Now let us take a integer variable result and let's assign this with 0. Now use for loop for int num colon nums. What I will do, I will say result equal to result XORed with our number. Okay, then finally I will return result. Let's run this. It got accepted. Let's try to submit it. Okay, so this is the most optimal solution. If you like this explanation, please consider subscribing to my channel and also like this video and share this video with your friends. And also if you have any feedback or any comments, you can add that as a comment in the video. Thanks for watching the video.